Welcome everyone to a session on the InterSystems Package Manager. How many of you are familiar with IPM or under its previous name ZPM? Ooh, a lot of people. So this is going to be a great session. We're going to fly through a whole bunch of stuff. So for those of you who don't, I'm going to start covering how it all began and a little bit of what the basic functionality is. So my name is Bob Kuszewski. I'm a product manager at InterSystems, and with me is Emma Neal and Eric Chen. If you guys want to introduce yourselves quickly.
Sure. My name is Emma Neal, and I am a developer on the HealthShare team at InterSystems, and I work on DevOps.
Hi, I'm Eric Chen. I'm a platform engineer in integrated platform engineering, and we handled a lot of the artifacts that InterSystem creates.
Awesome. So we've got a jam-packed session for you today. So we're going to talk a little bit overview of what is IPM. We're going to talk about the new ORAS registry support, and we're going to do some demos. It'll be great. We'll have fun. All right, what is a package manager? So how many of you have used a package manager for any language before? Everyone, yes, because every programming language has a package manager. So Maven for Python, NPM for Node, all of that stuff. IPM is package manager for the InterSystems family of products. What goes into it? An IPM package encapsulates everything that you need for your application into one bundle that you can then move from one machine to another and deploy, just like you do for any other package manager in any other language. This is going to be a theme for my little section. It's all going to sound very familiar to the developers. So you can package up your Iris routines, your Python, your Java, your web apps, kind of all of the usual stuff that you need to do. It's a simple way of taking your application, putting in dependencies in between these packages, letting you move that from one system to another, or distribute it to your customers, all of that kind of stuff. When you take an IPM package from a registry, we're going to talk about the word registry in just a second, you install it into a namespace on an Iris server. So here I've got just kind of an example of, hey, I've got my app and I'm installing it into some customer one namespace, right? When you download it from a registry, we've added a whole new set of types of registries. So in the past, we've had a built-in registry that it knows all about. We're changing that so that you can use a container registry, that you use for your Docker containers for your package managers. So to talk about that, we have Eric.
Hi. So we recently released version 0.10.0 for IPM, and like Bob said, one of the new features that was added was support for ORAS-style registries and packages. So there's a lot of acronyms here, bear with me, but what is ORAS? ORAS stands for OCI Registry as a Storage, and OCI stands for Open Container Initiative. OCI is a collaborative project of many companies that come together to define a common spec for how we use and interface with container technology. Some people here might equate Docker to containers, and you wouldn't be too far off. Docker was one of the major players that popularized the container technology, and they are one of the major contributors to the OCI project. Docker donated the V2 spec that they created to serve as a basis for the OCI V1 spec, and they are highly compatible with each other. There are some differences. Some endpoints were removed, some were moved to optional features, but for the core functionality, they are essentially identical. And with OCI being a thing, some very smart person out there took a look at OCI and said, hey, that registry spec, we could use it to store more than just containers. We could use it to store, well, anything. And that is how ORAS was born. So if anyone is interested in learning more about ORAS, here's a nice short link that you could go check out after this session. So Why did we build an ORAS support into IPM? Well, there's a lot of benefits with using this technology. First, there's a very robust tooling ecosystem that surrounds OCI. Let's talk registries. There are many registries out there. Some are cloud-hosted, some are open source, some that you can run on your own hardware. Examples include JFrog Artifactory, Sonatype Nexus, AWS ECR, and GitHub Package Registries. These are all either OCI registries or OCI compliant registries that could be used to store OCI artifacts, and now IPM packages as well. There are some features that IPM uses that is part of the optional spec of OCI, and that is not fully supported by these registries. But for the main functionalities of being able to download, upload, and install from a registry, these are all fully supported. Next up, scanning. Scanning is already very well supported in the container ecosystem. InterSystems scans all of the containers that we deliver to our customers. And with the scanners that we're using, as well as many other ones out there, we see that they've already added rudimentary support for scanning generic artifacts as well. One of the uses for ORAS is to deliver large language models for use in AI applications. And so you can see there's a lot of interest in having good scanning solutions for these artifacts. We expect there to be greater adoption and greater support for these processes in the future, and we also aim to scan our IPM packages as well. Next, signing. Unfortunately, at this moment, signing support is fairly lackluster for containers. Most people just use the checksum that is built into the OCI spec. But like I said earlier, many of these artifacts that are being shipped are highly sensitive, and so people want signing support. We do see a lot of movement in the industry to build solutions for that, and we also aim to have all of our containers and packages signed as well in the future. Next, CLI tools. There are many tools out there that are helpful for you to interact and interface with the OCI specs. For registry spec, there's the ORAS CLI, which we'll talk about a bit more later. Next, another great benefit of ORAS is portability. Portability is built into the spec itself, and it is also something that's very important to many of our customers. A lot of companies have strict requirements on being able to vet packages and only deploy packages that have already been approved. With the vast registries that are out there, you can use IPM to download a package, spin up your own registry using one of the ones we mentioned earlier, or another one, and then go through your standard vetting process to say, hey, this is ready, we're giving it the stamp of approval, and then republish it into your own registry for future consumption. On the back end, ORAS artifacts are also nicely bundled together into a tar.gz file. So if you're in an environment that's air-gapped, you could use something like the ORAS CLI to pull down the package as a tar.gz file, move it across your air gap, and then re-upload it into your own registry. You could also store it as a file as is. You'll lose some of the versioning functionality that IPM provides, but it is there. Last thing from me, many of you will know that we distribute our containers through the InterSystems Container Registry. Well, now for IPM, they're OCI, they're highly compatible, so we're leveraging the same technology to now distribute IPM packages in the InterSystems Package Registry at this URL here. So I'm going to hand this over to Emma to go through a demo.
So I come to you from an application development perspective, and what I care about, and what I suspect many of you also care about, is how do I actually use this to package up a module that I have written, to publish it to an ORAS repository, and then to pull it down onto an instance so that that can be used by me for development purposes or by my customers. So I'd like to show you a small use case of that, and I'd like you to notice how easy it is. Okay. So first, I'd like to show you this teeny tiny module I've got over here, which just contains one class with a hello world method. I'll zoom this in one notch. And at the root of the module, you can see the module.xml file, which is the manifest file for the package. It contains metadata about the package and what should be contained within it. So we've got the name, we've got the version, and here is where you would also include information about any dependencies to be packaged up together with the base module. So I'm going to walk us through installing this module and then packaging it and publishing it. So first I'm going to open up an Iris session for this ready demo Iris terminal. It's 2025.1 Iris version. Switch into a namespace I've created called IPM-NS1. And the first step in this process is to actually install IPM, the latest version of IPM. Note that it will be included in Iris 2025.2, so this will be quick and easy for you in the future. And the way that you do that is you go to the open source IPM GitHub page, you scroll down to releases, you pick the release you'd like to install, and you simply download the XML file and load that onto your instance in any way you'd like. So today, I'm going to, I've actually pre-downloaded it. Here it is. And I'm going to just use system.obj.load to load it in. Now ordinarily it takes a minute, I've preloaded it, but you can see it's successful. So let's go ahead and test that out by entering the IPM shell. Yes, it says ZPM, do not be confused. So this is your little welcome screen. It tells you the version of IPM that we've installed. And before we get to installing the module, we need to configure a repository so that it knows where to look for the module. Okay, great, we've got none configured so far. So I'm going to run the repo command. I'm going to pick one for file system. I'm gonna call it test module repo, and I'm gonna point it to this location in our file system. Okay, awesome, it shows up as available. So we're gonna move forward with the install command. Okay, this, no need to worry about it too much. It is output related to the lifecycle phases that the module is moving through to be installed. Okay, I'm going to quit out of the IPM shell, and to prove to you that this was actually installed, we're going to try to run that hello world method. Okay, cool, hello world. So the next step is to get back into the shell, set up a remote repository to which we're going to publish this module and then actually publish it. So Eric has set up an AWS EC2 instance for me. Thank you, Eric. And we will be publishing to this repository. So to configure the repository, we're just going to run this repo-o command, pass in the URL, username, and our token. And looks like it's available. Wonderful. So we are going to go ahead and publish, and if you're wondering where this name is coming from, that is the name of our module in the module.xml. So we're going to run the publish command, which also will package up the module and any of its dependencies. Great, so a bunch of output, but the most important thing is that we reload the module, we package it, and then we publish it to the repository that we've named. And to prove to you that it was actually published, let's go ahead and do a repo list modules command. Is that the right version? Yep, looks like we wanted to publish 1.0.0-beta.4. Cool, so let's say I've got another instance and I'd like to install this on that one. That may be, so for the purposes of this demo, you need internet access, but know that IPM does support installing a module from a local tarball, so you don't always need internet access in the case that your instance is behind a firewall. All right, just gonna open up a new terminal and go ahead and cd into that Iris instance bin directory. Go ahead and start the Iris session. I promise you it's a different instance. We're going to open up the shell, the IPM shell. You can tell that I've pre-installed IPM on this instance already. We're going to run list installed so that you can see that nothing but the IPM module itself has been installed. And we're going to run a repo list. You can see I have actually already configured the AWS repository from which we'll be pulling the module. And let's try and install it. Okay, waiting a second. The command is install and then the module, and then we've given it the version in case there are multiple versions published to that repository. Okay, it appears to be successful. Let's test it out. Quitting out of the IPM shell, and then let's run that hello world method. Okay, wonderful. So that was really easy. And you can try this out tomorrow, tonight, if you would like, with a module of your own. You saw where the IPM artifact lives online, and if all you need is a running Iris instance. But I also recognize, as a HealthShare developer, that most deployment use cases are a bit more complicated than this, and so you're probably curious about a number of other things. For example, how do I set up my environment so that it's ready for a solution to be loaded into it? How do I configure the solution once it has been loaded, and is that going to take a bunch of manual steps on the customer's part? And the answer is no. So in HealthShare, we have worked on a deployment mechanism for, well, there's a number of solutions coming down the pipeline, but the first one is for electronic prior authorization, which if you attended the keynotes this morning, you'll hear is a huge pain point. So we're very excited to be pushing that product out the door. It's already released, and it is released and deployed as an IPM module. So how are we doing that? I've boiled it down to 5 steps. First, customer would install Iris, or in the case of this electronic prior authorization, Iris for Health. Then they would install the latest version of IPM, just as I did. Next, they would set up their instance environment. Next, they would load the component into the namespace with either a load or an install command at the IPM shell. And finally, they would configure their solution. So in HealthShare, we have chosen to do this using an Iris native mechanism called the configuration parameter file. And just quick show of hands, who has heard of the configuration parameter file, or CPF file? Okay, that's quite a few people. For those of you who haven't, this is an Iris native way of applying configuration from a flat file. So one of its advantages is that it supports executing arbitrary object script code, including IPM shell commands. And similarly, IPM supports configuration that is implementation specific. So I'll talk a little bit more about that. But we've used the CPF file to orchestrate deployment because it can do steps 3 through 5. So I'm getting a little bit ahead of myself because I'd also like to give you an overview of the files involved in a deployment. So first, you need the IPM artifact. That's that XML file that I just loaded onto the instance, first thing. Second, you can create a configuration parameter file with any instance set up. So that might be creating a namespace and a database into which you would load an application. That could be creating roles and resources, granting SQL privileges, anything that you need to set up your instance. And then you would run an IPM load or install command to actually load your component into the namespace you've created. And then finally, and so that requires actually having that module on hand, either in a remote ORAS repository or in a local tarball. And then finally, IPM supports, sort of similarly to the CPF file, applying user-specific configuration that has been defined by the module developers, and it supports applying that in any way that the module requires at deployment time. So you would do that via flat file configuration JSON file. So at least in HealthShare, we are quite excited about the possibility of deploying in this way because it opens up this possibility of deploying independently of Iris itself. So instead of shipping a whole kit, you're shipping this IPM module that can be installed and upgraded independently. So take electronic prior authorization, for example. You've got one solution comprised of 3 IPM modules, each of which can be installed and upgraded independently. And that is very exciting, and we hope that that really reduces the burden of upgrades for customers. Yeah. So I'll pass it off to Bob for some final remarks.
All right. We are out of time, but thank you, everyone, so very much. There's a whole bunch more info about IPM. It is an open source project. We are building it in the open on GitHub. We still kind of manage and control that, but at the end of the day, you can see what the source code is. You can see what it does. There's documentation that's out there. It will be included with 25.2, but it won't be pre-installed. Just means it's a one less step for the installation instructions. And a big shout out and a thank you to all of the people who have contributed to this project, a lot of people inside InterSystems, but also a lot of people outside InterSystems. I'm only talking to you about this today because Tim Levitt is gonna have a baby any day now. Had a baby, ooh, that's exciting news. So, congratulations to Tim. Anyway, if you have any questions, comments, concerns, we are totally out of time, so you can just catch us afterwards. Thank you all very, very much.